Hey everybody, it's Coach Hammock coming to you from beautiful Georgetown, Texas here in room 132. Hoping you're having a great day. Let's jump into it and get going. We got a lot of slides, but it'll be pretty quick. All right, so if it'll work. All right, so we've graphed quadratic functions. Now what we're going to do is we're going to translate those. We're going to move it around. And we're also going to know what dilations and reflections are and all kinds of stuff. All right, so here's your vocabulary. Transformations, translations, dilations, reflections, and vertex form, which is a new way to look at the equations. Not going to do a lot with that, but that's at the end, so let's get going. Okay, vertical translations. Basically, guys, if you look at this, we have our parent function. Our parent function is y equals x squared. So with vertical translations, we're going to add something to the end. Basically, if we added plus 0, that's going to be our our y-intercept at 0, 0. Okay? But when we add something here, and let's go bigger than 0. K is greater than 0. It's going to move that y-intercept up. If k is less than 0, it's going to move it down. Okay? And I'm saying k if you look at this formula right here. All right? So don't get real caught up in it. Just know that it's showing you where it's going to cross the y-axis. Okay? So describe how the graph of x squared plus 10 is related to x squared. Well, if you think about it, x squared is going to be something that goes like that, and x squared plus 10 is going to be something that goes way up there. Okay, it's going to be the same as far as the stretch and everything like that, but it's going to be way up high. It's going to be 10 units higher. Okay. Describe how the graph of x squared minus 8 is related to this. Well, if you look at it, it's translated 8 units down. The graph stays the same. See, these are the same, but it's translated 8 units down. Okay? So describe how this graph, x squared plus 7, is related to this. Well, h of x is translated 7 units up. Okay, because it's got plus 7. And this is just a plus 0. So hopefully that's right. What was our answer on that one? I think it's right here. H of x is translated 7 units up. Yeah, it's A. Okay. So what about if it's horizontally? Okay. And honestly, it talks a lot in here about if it's in this form, the graph of this is translated if h is greater than 0, if h is... The easiest way I've found to teach this, guys, is graph both equations and see where they end up. Okay? If I give you two equations and say, what is the translation to this? How is it translated? Just graph them both and see where the vertexes are. Compare vertexes of the lines. So if I look at this, x plus 1 squared is related to x squared. Well, blue is the x squared. And the g of x, the red right here, is going to be your x plus 1 squared. And if we compare the vertexes, there's one vertex, there's the other vertex. How is it translated? Well, it's translated to the left 1 unit. All right? So if you look, here's the 1, and you just got to know that it's translated that direction one time. Okay? It really has to do with when you FOIL this out, we get a y equals, or a y value, a y-intercept of a 1 right there. And that's why it's got to move over to the left. So if we were to compare these, how are these translated? We start at blue, we end up at red. How is it translated? Well, it starts here, ends up there. 4 units right. Okay? And again, my y-intercept on this one is going to be positive 16, so it's way up there. Okay. All right, so we're going to describe what if it's both. Describe how this is related to x squared. Okay, so we start with the blue, and then honestly, I'm just going to take this and I'm going to graph it. Okay, you could do an XY table. That would be very easy in this case. Or you could just punch it in your calculator and see what happens. Okay, so I just compare this vertex and this vertex. Well, it looks like it just moves over to the left 1 and up 1. So that's all I'm going to say. Left 1, up 1. Sorry about the little break in action right there. Dorhauer called me on the phone. Hey, that might be a great bonus question tomorrow. Who interrupted the video? All right, so here we go. All right, so we're going to graph this and this right here. So again, we're looking here, and I don't think it's supposed to be x squared. I think it's supposed to be x minus 2 squared. Okay, plus 6. So I'm right here, and I'm right here. Well, and this is something that you're going to have to really watch out for because these are not 1 units. All right, it's 2, 2, 4, 6. So it's translated 6 units up and 2 units to the right. 6 up, 2 to the right. Okay, this stuff's pretty easy so far. I hope you agree. All right, so describe how this is related. Describe how these are related. We're going to start here and we're going to end right here. Again, you can pick any point, but the vertex is the easiest one to see and it's the easiest one to compare. So for this one, I'm translated 4 units to the right, 2 units down. Translated right 4 units and up 2 units? No. Translated right 4 units and down 2 units. That's what we are. Okay. All right, so what if it's a dilation? Now, a dilation, when you get your eyes dilated, it changes size. It causes your pupils to dilate. It changes size. So we could have a dilation where it gets more narrow. This is called a stretch. Okay, stretched. Or we could have it where it gets flatter, more flat, and that's called a compress. All right, so you can think of it as you kind of grab hold of the line and you pull the edges in or you push the edges out. Okay? All right, so if all depends on this number right here. And if you look at this, it's going to show you if the absolute value is between 0 and 1, it's going to be a compression. If the absolute value is greater than 1, it's going to be a stretch. Well, this is between 0 and 1, so this is a compress. All right, so just hypothetically, if I started it like that, then my next one is going to be like this. All right, and I know that that's a horrible drawing, but you can tell what it is. All right, describe how this graph is related to this graph. So we look, this has a coefficient of 2. This has a coefficient of 1. So this is greater than. So if I was drawing this, and I'm going to say that this is in blue, and this is my standard, okay, then this one in red is going to be a stretch. It's stretched vertically, all right? So this one is stretched from that. Make sure you're looking at which one is mentioned first, okay? All right, and it's not going to be stretched horizontally. It's stretched vertically. Okay, so describe how this is related to this. Holy cow, now we've got this part and we've got this. Well, I know that this tells me it's going to be a compress. All right, so I can go over here. Is it stretched vertically? No. It's compressed. Stretched vertically? No. It's stretched horizontally? No. It's compressed. It's compressed and it's translated 4 units down. Answer is going to be B right there. Okay, so what about reflections? Reflections have to do with the negative number. If it's a negative or if it's positive. Remember, we've talked about if it opens up, if it opens down. This should be a review session for us. Okay, so how does this relate to this? Well, we look, and this is now a negative. So it's going to be a reflection. It's going to be a reflection, and I'm going to say that this is my red. Okay, that's my red. And then my blue right here, it's going to be a reflection across this. And I can tell that it crosses the y-axis at positive 1 from this. And it's going to be a stretch because it's negative 3. Okay? Dilation occurs in which A equals 3, and a translation occurs in which C equals 1. So that's what it is. So if I was to say, how does this? It's stretched vertically, and it is reflected okay, up 1. There you go. Lots of stuff going on to that. Okay, so describe this. We have this and this is different. So the 1/5 is going to tell me that it's a compression. Okay, it's a compression, and the -7 tells me it's moved 7 units down. Okay, now when we look at equation, if I was to give you this in a multiple choice, what is the equation shown? The first thing I want to do is I want to look at this point right here. Okay, if it's on the y-axis, I want to find where it crosses the y-axis. That crosses the y-axis at -2. -2. All right, so I'm looking C, nope, it's at +2. B, it's at +2. Okay, so now what I can do is I can try to find a point that I think crosses exactly on the point. All right, so I'm going to pick this right here. Okay, so x is 1, 2, 3, y is 1. So is there a number where I can put 3, 1 into the equation and see if it works? Well, let's see. If I put a 3 right here, 3 squared is 9. 1/3 of 9 is 3. 3 minus 2 is 1. So A checks out. Let's try this one. 3, 9. Oh, there's a negative right here. So -3 plus 2 is -1. Oh, and I did the wrong one. I needed to go right here. So if it's 9, -27 minus 2 is -29. So I know it can't be D. I also know it can't be D because of this negative sign right there. So my answer's got to be A. All right. So let you look at this real quick and answer it. Okay, so the first thing I'm going to do is crossing at +3. Well, there's a +3, there's a +3. Goodbye A and D. All right, it opens down, so I know that this is a negative. If I wanted to pick a point, I could pick that point right there or that point right there and try it and see which one works, but I know it's got to be C. Okay, now the last part we have here is this vertex form and standard form. Standard form is what we've been working at. Vertex form is a little bit different. So when you see this, you have a point, okay, contains this point, and this is the vertex right here. Okay, sorry for that break, guys. Mallory had to come in and get her lunch. Yet another person, also Coach Colson, came in and got keys from me. So lots of interruptions today, but oh well. Okay, so we've got this form right here. And if you look, we have an X, we have a Y. Now, on your vertex, your book labels this as point H and this as point K. If you look at vertex form, this top equation right here, it's got an X, it's got an f of X or a Y, it's got an H, and it's got a K. Basically, guys, what we're going to do is we're just going to take all these points, put it in, and solve. Solve for the A. All right? After we solve for the A, we can go through and we just put the points back in, and there it is. Okay? If A would have been -2, this would have been a -2 right there. But because it's just a -1, we're going to put a 1 right there. All right, so we have the same equation. What would it be in standard form? Well, all you do is you're going to multiply this out. You're going to expand it. So x plus 2 times x plus 2. And then you're going to distribute that negative to everything in there. Distribute it out, simplify it, and it comes up with your standard form. We'll work more on that tomorrow. I've got a long video going right now, so I want to end it real quick. Any questions, bring them. Make sure you get your whisk done. We'll see you tomorrow. Bye.